Today we're going to be doing a question and answer about the Flow Mach 500 water jet that you see behind me. I'm going to be answering all your questions from how did this big gigantic thing get into the shop? What kind of life support does it take to operate it? How do you operate it? What kind of material does it cut? How thick will it cut? How fast does it cut? And then just basically its overall operations we'll take apart and we'll throw it in here and we'll actually cut it from start to finish, so stay tuned for that. So to answer the first question is, what is a water jet? This thing is actually pretty complicated, but in simplified terms we can take tap water, we can boost it through a pump. The water comes out of this nozzle at plus the speed of sound. We mix in some abrasive with that water that's exiting the nozzle, put material underneath that water cutter, and we can cut stuff with it. We have CNC control of the machine, so we can position that jet anywhere we want. So that's basically it. We can cut a vast array of materials with water. So that leads me into the next question. As you can see, this machine is huge. How did I get it into this building? And we'll walk through that question now. The machine showed up on a huge semi-truck. Each component was boxed individually in multiple wood boxes. We had two halves of the tank, the two supports for the gantry that get bolted to the floor, the Flow Garnet hopper, and the 94,000 PSI intensifier pump. The tank is approximately 20 feet long and 10 feet wide, with a cutting capacity of 8 feet by 12 feet. There was nothing special that needed to be done to the floor, as long as the floor was somewhat level. It's sitting on 3.5 inches of concrete. The machine itself, the moving components, are isolated from the water tank. It took about 2 to 3 days to install the machine. We just bolted the two tanks together with this cool gasket. They smashed this piece of hard rubber. It almost feels like a glue stick. And it's one big, huge, long piece that drapes and goes in between the two parts, and then they get bolted together. And this, I don't know what you call this thing, piece of rubber, some fancy rubber, gets smashed into like a pancake, and then put a piece of 1/2 inch flat bar so that the water jet doesn't cut it. And yes, this machine will cut the floor of this tank if it's held in one spot too long through the water. And in some cases I've heard that a customer that owns these things will put a AR plate down on the floor. One of the questions I get all the time is, how much water does this thing use? It is a water jet, right? But it actually doesn't really use that much. It just uses the water line from the building, which is about, this is about 15 gallons a minute, but it really only takes about 5 gallons a minute to support this machine. But the first place that the water comes from the building is to this water filter over here. You don't really need filtered water if you got clean, but it just helps keep the components a little bit cleaner. And then from the water filter enters the intensifier pump. This is where all the magic happens. This is what makes this cool, is the 94,000 PSI intensifier pump. And how this thing works is a 50 horsepower electric motor that's run off of 100 amps from the building. The hydraulic pump pressurizes the pistons inside here, and this piston moves back and forth. And at the ends of those pistons it's necked down to a smaller rod, so we're gaining some mechanical advantage, and that is now compressing the water, sending the water out the lines and into this accumulator. And the accumulator's job is to take the pulses out of the strokes from the intensifier and just basically give the cutting nozzle clear, pulse-free 94,000 PSI water. Once you get to about 400-500 hours, it takes about an hour and a half, and you can rebuild the pump right here in the shop. And it's pretty cheap to actually rebuild these things. I just got back from a class to learn how to do it myself, so I'm excited to be able to maintain the pump myself right here in the shop. Let's take a look inside at the hydraulics. So this is pretty cool. There's our big 50 horsepower motor. That thing's awesome. And then our hydraulic pump. So what we have also is the water coming in from the filtered. It's going through a coolant system, and the coolant is just keeping the pump cool. The intensifier pump does not recycle tank water. It's always seeing clear, clean water. So out of the accumulator, the water is now pressurized and it's hops into this hard lines, and this is it. This is where the water goes. It follows the hard lines up and into this, what we call the whip stand, this flexible flagpole, and it follows the gantry. When the gantry is moving, it gives that flexibility so this hard line doesn't get a kink in it. The water enters the movable head of the gantry, or this, what we call the Z-axis, and it's still hard lined into, this is a 5-axis XD cutting head, which it's going to be able to rotate in 5 dimensions, and it enters this cutting nozzle right here. The garnet and the water are mixing together, and it's exiting out of this nozzle at way above the speed of sound, combining into this stream, and this is what actually does the cutting. So now let's talk about how the garnet actually gets here also. It has its own path on how we get to the cutting head. So let's go talk about that now. Why do we need garnet? Well, garnet is an abrasive. It's a hard natural mineral that gets mined, and the garnet is what's actually hitting the material and causing some erosion to whatever we're cutting. And it's the more garnet you can throw at it, typically the faster you can cut, or you can combine it with water and speed up that garnet even faster and make it cut faster in that way too. So this is a 2,000-pound pallet. I choose to get the garnet in bags, so it's just easier to handle for me. You can get big sacks of just straight garnet that is not individually wrapped. Okay, this is what the garnet looks like. It's kind of hard to see, right? This will actually hold, what, 800 pounds? It doesn't look like it, but it'll hold quite a bit. The hopper has like a warning light, so when it does get low, here's the sensor right here, that it just beeps at you and says, hey, you're running low on garnet. So you probably still have a good hour's worth of cutting when that light comes on, so it's just more annoying than anything. There's a diaphragm in here, like a bladder. So it's a rubber bladder that squeezes just like that. When it's asking for more garnet flow to the head, the bladder opens up and it closes. It opens, it closes inside here. And it does that from air pressure. So the shop air, you need quite a bit. I have 53 CFM air compressor, rotary screw air compressor here in the shop. I'm thinking you probably need at least 20 CFM to be able to run this machine and your other shop tools. And it needs clean, dry air to operate this. But that's basically how it works. That when the computer control is asking for garnet, it gets funneled down into this hose. You can see it's just draped down here on the floor. And then you can see it run behind me, and it's in this clear hose. This is all full of garnet. And it just makes its way through the machine and through the track, and it's just getting pushed up by vacuum, and the air pressure is just pushing it up into the machine and into the gantry and up and over and in. And you can see the garnet come into this little mixing chamber right here. And if we take this off, you have what you call a metering disc. This is what controls how much garnet is getting sucked into the machine. Because remember, this has a vacuum. It would suck your finger. Picture it like a carburetor in a car. You don't want to run too rich of fuel, and you don't want to be too lean either, because the computer knows how much garnet is supposed to be flowing. So it's going to change its speed accordingly to the thickness of the material. And when you get a clog, you take this apart and you blow the line out and you're off your running again. Is the garnet reusable after it's come out of the nozzle? Can you recycle it? And the answer is yes and no. There are machines that you can now clean the tank out, put this garnet into a machine. It will separate all the yuckies from the good. So you can imagine what's in the bottom of this tank. There's aluminum filings, steel, wood, plastic, foam, a whole bunch of stuff that's stuck in with the garnet. Garnet is just one of those things. You want it clean. It's what you don't want to have problems. And two, when that garnet hits the material, it basically explodes. So it doesn't have the mass that it may need to be able to cut again. So yes and no, but mostly no, you cannot reuse it. There's a few ways to get the garnet out of the tank, and so you can imagine that once the tank starts to get full, you're going to want to remove it. The cheapest way, kind of, is just to literally remove the slats and use a shovel and shovel it into a bucket or a trash can and then haul it to the dump. You can tell that every pallet of garnet that goes in is going to end up at the bottom, so that can take a while. Another way to do it is I've seen guys have an excavator. They'll literally scoop it out like it's dirt and haul it away that way. The next way is you can actually buy from Flow is an auger system, or it's continually cleaning the tank basically and depositing the garnet outside of the tank into a big dumpster container in a big plastic bag, and then you can haul it away that way. Or the best way Flow recommended to me is to bring in the septic tank guys or the vacuum suckers, and they'll literally just vacuum the slurry out of the bottom of the tank, and you do that bi-yearly, once a year, every 3 months, depending on how much garnet you're dumping into this thing. You guys asked me, what is all this thingamadoohickey hanging off the side of the cutting jet? And this is an XD 5-axis head, and so it tilts back and forth from this joint right here, and then it actually pivots up at the top right here. And what this allows you to do is this cutting jet is now able to cut in any degree up to 60 degrees. So this can lay over 60 degrees at any angle. This is an accessory that Flow sells. This is called the compass, and you put this attachment on the end here, and it goes around the nozzle, and it floats up and down, follows your material, and it helps keep you from crashing the nozzle into your part. The 5-axis helps with taper, because anytime you cut the water is actually causing a taper. This has a compensation for removing the taper out of a part. So that's why you're seeing this thing dance all over the place, is it's optimizing your cutting angle. Picture the cutting angle as the water hits the part, and then the garnet and the water lose speed, and it kind of trails off. So it's trying to keep that trail straight and perpendicular to the part. This is I call it like the blast shield, because this nozzle will lay over that far. It's kind of like an umbrella to try to keep some of the spray down. And these are just a consumable item for that. The cutting head has what we call an orifice, and this is the first thing that the water sees, and this is what actually builds up the pressure here, and it looks something like this. Okay, so check this out. Inside that cutting head you have your diamond orifice, which is 10,000ths of an inch. There is actually a little tiny diamond in there, and the water now has to move through this little tiny orifice. This is what pumps up the pressure, and this is like holding your thumb over the end of the hose. Now, there is a space between the diamond orifice, what sits up in here in this head, and the mixing tube. So because there is a space in here, you can see that it's going to actually cause a vacuum, because that water is moving so fast now, and it actually will suck garnet into this chamber. There's a hose back here. This is the garnet flow. I can pull it off. There we go. You can see there's a hose that sits like that. So if we want to cut with garnet, we have the option there, and this is how it gets into the water mixture, is from vacuum between the diamond orifice and the tungsten carbide mixing tube. This is an air actuator. This is actually what turns the water on to the nozzle. There's a little plunger in here that allows the water to go down, and this is air controlled. What is the benefit of having 94,000 psi of water pressure and the garnet? To answer the first question, the higher the water pressure, it will help with cutting. So it's kind of in the debatable is that, oh, you don't need much water pressure, you just need to throw more garnet at it, because the garnet is actually what's doing the cutting. It's like an abrasive or sandpaper. There really isn't any cutting action really going on. It's more of just kind of like sanding the parts or sanding the thing apart. But there may be times where you don't need garnet as the cutting media. You can run just straight water. So a lot of food processing plants, if you're cutting anything with scissors, if you can cut a material with scissors, you can run just straight water. So the higher the water pressure is, the thicker the material or the more dense material you can cut with just water. And it's debated that you don't need this much water pressure, but if you think about it, the evolution of water jet machines is they've gone from 20, 30, 40, 50, 94, and I know that they're working on 120 PSI water jet cutters at the moment right now. So it's naturally the evolution of the machine. The more water pressure, the better. Having the higher water pressure doesn't necessarily mean faster cutting times. It's just going to help you with Garnet consumable. It's going to help you not have to use so much Garnet. This uses about a little bit less than 1 pound a minute of flow rate of Garnet. So if you can cut that down, it's going to save you money on cutting parts as your overhead costs. One of the most popular questions that's come through is that what can this machine actually cut? And the answer really is just about anything, really. Everything from metal to food. So this machine gets used in the food processing. Believe it or not, your chicken nuggets that you eat are probably cut on a water jet. The cheesecake that gets cut on a water jet. Thick material like steel, no problem. This machine's capability is about 1.5 inches. I have cut a 3-inch thick plate with it. The thicker the material, just the slower it goes. What I've noticed when I'm cutting something is it's cutting about the speed of a bandsaw. The surface finish, I can change the surface finish how I want it to be. If I want it to be a smooth cut like that, I just slow the machine down a little bit. So that's some versatility there. It's not limited just by cutting a piece of solid. You can stack sheet metal on top of each other and it'll just blast through layers of material. It really doesn't care. Like I said, if you're not careful, it'll cut through your material and through the floor of the machine if you keep it in one place too long. So it really is not limited to by the thickness. Tube steel, you can cut through one side of tube steel and it'll poke out the other side, which is good and bad. There is sometimes if you don't want it to cut through a layer, you're going to have to add a diffuser material in between. So just picture that nozzle, that water, like a laser beam. When you shine it through, it's just going to keep going. The material doesn't have to be clean that the water jet cuts. As you can see, it's rusty. There can be mill scale on it. It can have paint. It can have grease. It can have anything. It just cuts right through it. When the parts do come off the tank, they are clean and bright, almost sandblasted like. So the first thing you want to do is just hit them with a blast of clean water to get the garnet off of it, and then blow them down with compressed air to dry them, and then they normally don't rust after that. But the machine does not care if they're rusty or not. You can turn the pressure down. You don't always have to cut at maximum pressure, and you can etch a surface. I actually have plans to make a cool chessboard and etch a surface into it and make a chessboard. So you kind of think about some ideas about doing that kind of stuff too. Let's throw this piece of 1/4-inch plate on here. And the machine knows that it can't come too close to the edge because it'll actually poke a hole through the side of the tank with the water over traveling. So I just know that from experience that I got to push it in more. This is one thing you have to talk about is just the material handling. My favorite tool is this magnet, which I keep over here on the side of the machine all the time. This little magnet will do 250 pounds. I love it so much that I started carrying them on the website so that you guys have easier access to finding them. This is a mag switch product, and it will do, I think, 250 pounds, one of them, which is fantastic. One of the other reasons I like its size, so that if I can stick it to a part that I've cut out, and I can just grab it and pull it out too. So it's really cool for that. So if you have a small plasma cutter, this is a great option in a forklift to use. Flow gives you these cool little toggle clamps, and they sit on top of these 6-inch ribs. These are disposable, or they're a consumable product. You can see it just cuts right through them. You can see it just blasts right through the support ribs, and they're in an S curve so that there's no vibration. And this goes underneath the rib and then holds your part down. So it just kind of goes down like this. You give it your 90. And then of course you run the screw down. First thing I do in the morning is I come and turn the main power to the pump on, and then I come to the control panel on the side of the machine and I give it power. And the control panel, it's got a hard drive that's stuffed underneath here, and all the exterior controls are all waterproofed. We have basically two programs. We have the design and drawing software, and that's called Flow Path. And then you have Flow Cut, which is how we control where we want the machine to go. So the first thing I do is I go into Flow Path. So let's just draw a simple 2x2 square. Okay, and now once I have the square drawn where you're drawing, I want to select it, and then I want to auto path it. So basically it's saying it's creating a path for it's going to talk to the machine and tell it where to go. And then I'm going to go into Flow Cut. All I got to do is just import it. So now we have to say, here's our square that we drew. I want to give it its parameters. So you type in how thick you want to go. And then you select the material that you're cutting, and it's labeled from easiest to cut, rubber. You can see all these different programmable materials. So you select your material: Delrin, fiberglass, Kevlar, micarta, phenolic, nylon, quartz, limestone, brake pad. Literally a brake pad on there. It's funny. And these are all what Flow has set up to known for speed, how quickly the machine should cut for the hardness. And we're still scrolling through all the way to gray iron, stainless steel, and then the hardest is tungsten up here, and PCD, whatever PCD is. Somebody in the comments will know what PCD is. Let me know. So let's select, we're just using mild steel. So I'm going to select, whoops, passed it, mild steel right there. And then the tool radius, this is the actual diameter of the water that's coming out, and I know this is 18. Okay, and then up here in the corner, these are our percentages. So 20% being the best, 100 being the fastest, and then of course you can do custom speeds in between there. So let's do 60% cut speed, and I hit OK. That's what I want to do, and I hit Run Machine. And when we first started up, we wanted to Z all the axes, which it just did. And as you can see, I can move it around with my controls on the computer. I can move it left, I can move it right, back and forth. So before we get started to cut this little square out, I want to give you an audible sound of the garnet as it breaks the sound barrier. So I'm going to bring the head of the cutting about 12 inches above the water, and I'm going to hit water on. So water is only going to be coming out of the nozzle, and then I'm going to hit the button and turning abrasive on, and then you're going to hear the difference between the two. So water on versus water and garnet. You're going to hear the garnet break the sound barrier. So let's do that right now. It's kind of fun. Okay, pump's coming on. Water only coming on now. Okay, abrasive on. Okay, abrasive off. Water off. Pump off. I like to do that test if I have a clog inside the nozzle, and I know that I make sure that my garnet's flowing good. If I don't have running the compass, that nozzle can get too close to the surface and plug the mixing tube up to where you gotta take it all apart and then clean it back out again. But this is a test that I like to do just to make sure my garnet is flowing. So the first step that we gotta do is find home. So what I gotta do is I just position the work where I wanna do my cutting, and I drop it down, the cutting head, to 100 thousandths off the work surface, and then I zero it and then call that machine home. And then that will line everything up from the computer and the machine are now thinking they're in the same place. And then I just find out where I want to cut. So let's just bring it to the edge, right about there. And now basically we're ready to cut. All I have to do is turn the pumps on and hit go. We're going to make a first cut. We're cutting this square. Pump on. Here we go. So that took only a few seconds, and what you can see is that the part fell out. What we can do is we can add what you call a little tab, and it's just a little piece of metal that's going to hang on so it doesn't fall in the tank. So this is another drawback of a water jet machine, is that your parts will fall into the abyss. We can put a backing board underneath. It's called a rhino board. It's kind of like a honeycomb plate, and it'll prevent that from happening too. So here's the square, and what I like about the software too is I can pick this entity and say I want to give it a specific cut quality. So maybe this edge is going to be visual or something, so I can select it and I'm going to hit 20%, which means it's going to have a really good cut quality. And let's just walk it around. Let's just select this one is 40%. Let's select this one at 60%, this one at 80%, and this one at 100%. So when this part comes out, we'll be able to look at all the different cut qualities. All right, let's raise the water tank, and inside of this tank is a steel bladder that we can pump full of air, and it's just going to displace the water inside the tank, and we can raise and lower the water pretty quickly. It should be a little bit quieter, and we're going to cut this rectangle out now, so let's try that. That was 100% cut right there. Now we're going to do a 20% cut, so it slowed way down. Cool. Let's look at that. Look at that. There's no cleanup. It's super nice. I mean, look how dirty this is. This is 20%. This is 40% on the side. That still looks really good. You can kind of start see a little bit jagged teeth. 60%. 80%. Cut quality is getting a little bit more chowdery. And then there's 100%. So overall, not too bad. Okay, we're gonna make this funny elliptical eye. This is a 45-degree chamfer on the outside and inside on this 1/4-inch plate. This would be super hard to replicate if you didn't have a machine like this. I wouldn't even know how I would make this part. So let's cut it out. Woohoo! So here's something cool to look for, is that you want to cut it upside down so you don't trap the part underneath. That would be, this is just a random sample part just for fun that I just sketched up real quick. But this is a 45° on the ellipse, so that's pretty cool. So when it's cut upside down like that, the part isn't trapped. If we were to cut it like this, which the machine could do also, we would have to unbolt the plate to get the part out. So you got to be smarter than the machine, I guess. You can get yourself to trap parts. But how cool is that? Man, the capabilities are just mind-blowing. And that edge is razor sharp. Pretty cool, huh? All right. Same test through some wood. That's scary. Whoa, now that was so epically cool. Look at that. What was cool is this was supposed to be calibrated for 1/4" plate, so. Okay, but that was just pretty cool. I've never done anything like that before. I normally don't goof around with this machine like that because this is not a toy. But yes, it'll cut wood. As you guys can see, it's a highly versatile machine. It may not be as fast as a laser or a plasma cutter, but this offers a lot of versatility for me here in the shop. It's also going to be making production parts for me in the future, and then it's going to help me with some prototyping in between those production runs. That's kind of why I chose the waterjet, for its versatility.